my student friends, myself Dr. V.D. Jadhav. We are going to study in BSc 1, CBCS pattern, semester 1, paper number 2nd for the chemistry, that is organic chemistry, DSC 6. That is unit number 1, introduction to organic chemistry. And this is the outline of my presentation in this today's lecture. We will discuss introduction. After that, curve arrow notations and cleavages of bonds with respect to organic molecular species, that is electrophiles and nucleophiles. And afterwards we will discuss electronic displacements, and lastly we will discuss reactive intermediates such as carbocations, carbanions and carbon-free radicals. So as far as introduction to this aspect of chemistry is concerned, we may describe this organic chemistry as clear understanding of molecular reactivity, chemical reactivity related to molecular structure, and when you integrate these two aspects, then concept that emerged out from this investigation is nothing but fundamentals of organic chemistry. So as far as curve arrow notations are concerned, this is the simple introduction where chemical reaction involves distribution of shared or lone pair electrons between reactants and within substrate molecule, which causes breaking of some bonds and making of new bonds between these atoms to give the product. The moment of electron within a substrate or reactant during reaction is shown by shorthand notation of curly or curve arrow. It offers several advantages which will be helpful to distinguish or visualize the bond breaking and making processes. It helps also for changes in the structural skeleton which are occurred in the substrate as they are getting transformed into the products. It simply represents movement of electrons in the substrate but not in the atom itself. It is drawn between the site of electron source to the site of electron deficiency, where one can have a tail which represents arrow where electron move, that is called as migration center, while head of arrow represents electron relocation, that is migration terminus. So as far as curve arrows are concerned, there are two types of curly arrows which are generally used in the organic chemistry, and they are: number 1, double-headed arrow, which represents the movement of pair of electron, and it is shown by double-headed arrow. So this is useful to represent ionic mechanism where heterolytic bond fission occurs. Now how it is drawn? It is drawn with its tail starting from center of a line representing a covalent bond or an atom having lone pair of electrons that is electron rich species, they may donate the electron density, and from where donation is taking place, that is represented by this double headed arrow. For example, we will look to this alkaline hydrolysis of methyl bromide, which is a well familiar example of SN1 reaction. So SN2 reaction. So here OH minus, which is having a more electron density, shares its electron pair towards this methyl group where bromine is attached, and now electron redistribution takes place in between these two species related to the formation of product that is called as methyl alcohol, along with removal of bromide in the form of Br minus. So here what happens? Lone pair electron on oxygen is shared between oxygen and carbon, forming new CO bond, while shared electron pair between this carbon and bromine is shifted towards bromine to form Br minus. So this is a very simple electronic bond movements that are represented in SN2 mechanism. In conclusion, what we can say is that due to electron redistribution, existing CBr bond in the substrate is broken and new covalent bond in methyl alcohol is formed. Second type of arrow is half-headed arrow, which is shown by means of fish hook. It is also called as fish hook arrow, which represent the moment of single electron. It is involved in the homolytic bond fission where movement of single electron occurs and there is a formation of free radicals. Therefore, it is useful in representing free radical mechanism. For example, here homolysis of methyl bromide, we will take it as a example. This is the example whereby methyl bromide carbon bond between bromine and carbon is broken in a symmetrical way in presence of heat or light following homolytic cleavage and producing these free radicals, which are called as methyl free radical and bromine free radical, where they are used in the sharing of this methyl bromide molecule. In conclusion, what we can say is carbon bromine bond in methyl bromide is symmetrically broken, where combining atoms they get one electron each, and therefore this pair is called as free radical. Thank you.